cloud data platforms have become the foundation for AI and analytics, but they're also one of the biggest drivers of enterprise cost. While Snowflake continues to dominate data warehousing, Databricks has been catching up fast, powered by its lakehouse model and explosive customer growth. And now, Espresso AI, a startup founded by ex-Googlers, says that it can help Databricks customers cut their data bills in half automatically. And joining me today is Ben Lerner, CEO of Espresso AI, to deep dive into this discussion. Ben, let's start with what's fueling Databricks' incredible growth compared to players like Snowflake and where Espresso AI fits into that story.
I think one is Databricks has a bunch of really great products, obviously. So they've done a great job and they're more developer focused. So when you go to Snowflake events, I think you see a lot of business people. And when you go to Databricks events, you see more developers and engineers. And I would guess that in the current environment where there's so much stuff to build, there's a bit of an opportunity for the developer-led thing to grow faster. At the same time, though, a lot of their growth is actually attributed to the product that we started working with, Databricks SQL. So Databricks a few years ago released their version of a data warehouse, and they're kind of quickly iterating on it, improving the product. And something that they've been able to do, they've grown it about 5x over 2 years. So it's about $1 billion a year run rate now. The reason they were able to grow so fast is they're going back to their kind of existing Databricks customers and getting them on this data warehouse. So to some extent, they've got like a supercharged sales funnel if you compare it to Snowflake or BigQuery or Redshift, where they already have a bunch of existing relationships that they're leveraging.
Obviously, Databricks and Snowflake have become the two big names in cloud data infrastructure, and there's a bit of rivalry there, which is good for innovation, competition, and customers. How do you see this competition shaping the broader cloud data market, and where does each platform hold the advantage?
It's really been interesting to watch over the past 2 years because, Snowflake and Databricks have this well-known rivalry. They did the thing, a couple years ago where they hosted their conferences on the same time in different cities so that you had to pick one or the other. But when you actually talk to consumers on the ground or to customers, like corporate customers, many people use both. It's very common to talk to a team and hear, oh yeah, well, we're using Databricks for some things and we're using Snowflake for other things. So I think it's a case of both companies having identified that they're sort of moving towards the same goal. And so Databricks now is building out with Databricks SQL a lot of the functionality that might have been more where Snowflake started. Snowflake is doing things in the other direction. They're trying to build out, they've released container services, and they're trying to do more managed compute for you. Overall, for customers, I think it's been great. One obvious example of this is all of the interest in Iceberg. So I think they've sort of pushed the industry forward to accept this open standard, and they're both really bought into it. And practically speaking, for consumers, that means that you can run either Snowflake or Databricks at much higher efficiency, and with data that is in your Iceberg, like in your AWS, in your Iceberg catalog, in a way that maybe wouldn't have been possible without competitive pressure.
Now let's talk about Espresso AI itself. What are you folks doing to help customers optimize their data workloads and manage costs more effectively?
So what we do overall is we use ML to optimize compute. We use ML to run compute more efficiently, and specifically today, we use it to run data warehouses more efficiently. We've had a Snowflake product for a while, and really excited to announce we just released our product for Databricks SQL. What this does is it uses ML and AI to understand your workload patterns, your traffic patterns, to understand what you're running and where. And it uses this to run these workloads more efficiently. You can think of it a little bit like what a Kubernetes scheduler or Borg scheduler does for cloud compute, but applied to data warehousing. Uh, the benefit for customers is that you just sort of flip it on. And in the case of Databricks SQL, we're seeing bills go down by as much as 50, 60%, pretty much instantly.
You have already helped Snowflake users cut data warehouse costs by as much as 70%. What made you turn your attention to Databricks now?
We are in the process of reaching out to customers. The number one reason that people don't buy something from us is because they're not using Snowflake. And often they're using one of Databricks or BigQuery or Redshift. Databricks SQL in particular has been growing super, super fast. And there's been so much interest in the platform, and it's turned out to be such a great platform for the customers that do use it. We just had a lot of people interested in, hey, we saw what you guys did for Snowflake. Can you help us out with this build?
Tell us a bit more about the new Databricks SQL optimizer. How does it actually work, and how does AI come into play in identifying and reducing inefficiencies?
We have common question for us is kind of what does the AI even do? Because it's not, you can't see the LLMs. You're not talking to a chat bot. You just sort of press a button and things run better. What's happening under the hood, and the reason that AI is really what let us build this tool, is we're using transformer-based models, so BERT-based models, LLM-based models, to process your traffic and to predict features of your traffic. If you look at how Databricks SQL works today, or how other data warehouses work today, there's some amount of tooling for scaling load up and down, right? So this is the basic cloud compute auto scaling of, I had a bunch of work come in, let me burst up more clusters. And the more machines you're running, the more you're paying for. That's how cloud compute works. What we're able to do is we're able to more finely predict when you do and don't need those bursts, right? So to give a really simplified example, just because you had 10 queries come in, doesn't mean you need to spin up an extra machine. They could be 10 queries that take a second each, or they could be 10 queries that take an hour each. We're able to much better understand which bucket those queries fall into using transformer-based models, so using kind of the modern wave of AI models. And so we're able to just make smarter decisions about how many computers do I actually need to serve this load. The practical implication when we say we're saving customers 70% is you used to have 5 clusters running this. Now you have 1, and sometimes you burst up to 2. That's a really normal result for us.
You ran a 6-month beta that attracted hundreds of enterprises, including Booz Allen Hamilton and Comcast. What kind of results did those early customers see, and what surprised you most from those pilots?
One of the differences for us between classic Snowflake is, our original Snowflake product is Databricks kind of has access to more and different machines. So when you're using Databricks SQL, you have the option of bringing your own hardware, which is their Pro or Classic plan. And you have the option of using their hardware, which is the serverless plan. We work best with serverless, and serverless, I think, is probably the product people should be on. So it's actually been a little bit of a education process for us of talking to customers, and in some cases talking to their Databricks reps, and trying to figure out, well, why are people on the old product? Why should people move to the new product? Why is this, what are the benefits here? And there's been more conversations around just what is your setup and how did it get that way? And can we help you improve that? The thing that I'm most surprised by, which is, maybe a weird thing to hear coming from someone who started an AI startup, uh, is how well our models are able to adapt between different platforms. Um, like after we got the initial data from our early design partners, we were basically able to get a prototype going in a couple of weeks by leveraging the models that we had trained on Snowflake workloads. Um, so really, ML is great and AI works really, really well. And like even for people who are in the field, it sometimes just works way better than you would expect it to.
One of your beta customers said that Espresso AI cut their bill in half with no lift from their side. How do you make that level of optimization so handoff for data teams? Is there really some kind of AI magic dust behind it?
Yeah, I mean, I think the answer is sort of the magic dust that we have is powered by $11 million in venture funding, and so there's a lot of stuff happening under the hood. The we I talked a bit about how we have models doing this, but the other thing that we're really able to do is make second by second adjustments to your workloads and how many machines you have up and running. Um, it, Obviously, humans can't do that sort of thing, but you could start approximating it by having a person make a scheduling decision every 5 or 10 minutes. You could, I'm making up a number, maybe you could get half of the savings there. And that would kind of give people a sense of, you know, how much time and effort would it take to start having these adjustments happen in real time. Um, it's a lot of work. And the reason that we're able to put all of the work into it is just because we're at scale. There's basically no individual customer where it would make sense to have this sort of R&D project to do optimization at this scale. That's how data centers work, right? I used to work on Google Cloud infrastructure, and you have hundreds or thousands of engineers solving problems that then get rolled out across hundreds of millions of dollars, billions of dollars of compute. And at that scale, it makes sense. But if you zoom in on any individual company, even a huge company is not going to have a 20-person team doing a research project for 2 years.
Stepping back a bit, with AI workloads exploding, cloud compute management has become a moving target. How do you see cost optimization evolving in this AI first world? And do you think that automation and AI agents will eventually take over these decisions completely?
I think so. Um, I think that this dovetails very nicely with the buzzwords from an earlier era of lift and shift and moving onto the cloud. And I think that part of what most organizations haven't internalized is that moving a bunch of physical, like shutting down a bunch of physical servers and moving everything into a hyperscaler data center, um, it is not like you can just kind of lift and shift everything over and not change what you're doing. But there are many, many more opportunities for optimization on the ladder because you can do things like adjust your compute, second by second or minute by minute, depending on the platform, because you have much higher network bandwidth. So you don't, you can start thinking about the data center less as, I have 5,000 different servers and more as, well, I have this one machine with a very flexible storage, very flexible memory, very flexible CPU. And how do I really expand and contract my usage to match peaks of demand? This latter set of optimizations doesn't really exist if you have your own machines. I mean, you can turn things on and off to save electricity, but that's not especially cost effective. So there's so much more return to these decisions. And at the same time, these new models really understand code and programs in a way that previous models didn't, right? And in this context, it's a little bit maybe not obvious that that's true, but it's the same kind of models that power things like Cursor and autocomplete and like LLM based autocomplete and all of that. obviously those models are much, much better at code understanding. And so all of that understanding also translates onto the back end of what do I run and where, how much hardware do I need, and what should I be paying for it. So yeah, I think that it takes a while to roll stuff out, right? I think this is you don't really want to vibe code your entire infrastructure backend, but I do think in 5 or 10 years, the way that people run software on data centers is going to look vastly different and vastly more efficient.
Espresso AI is still a young company, but you are solving a massive and universal problem. What's next for you? Any plans to expand beyond Snowflake and Databricks that you can hint at?
Yeah, so it's probably what you would guess. We're taking a look at BigQuery. We're taking a look at Redshift. Those are the other two very large data warehousing platforms. Past that, we're really are taking a look at compute generally. So the plan for sometime next year is to start R&D into Kubernetes. It's to start R&D into GPU inference. It's to take a look at the broader Spark ecosystem, including Databricks proper. All of these are problems that sort of have the same shape of I'm running massive compute at scale, and resource tuning is difficult, resource allocation is difficult, demand prediction is difficult. So how do I use machine learning models to augment these decisions and run things faster and more efficiently?
Ben, thank you so much for joining me and sharing these insights. It's clear that as data and AI workloads scale, intelligent cost optimization isn't just a way to save money. It is becoming the key to sustainable innovation. Thank you for your time today, and I look forward to chat with you again. And for those watching, if your Databricks or Snowflake bill are growing faster than your budgets, check out Espresso AI and its new Databricks SQL optimizer. And don't forget to subscribe to TFiR, like this video, and share it with your colleagues. Thanks for watching.